Welcome viewers, today we will discuss the mechanisms of the cardiac arrhythmias. Before going to discuss the cardiac arrhythmias, we must know that what is the arrhythmia. Cardiac arrhythmia is defined as when the heart deviates from the normal cardiac rhythm. So we must know that what are the normal cardiac rhythms. We already discussed the normal cardiac rhythms in our previous videos. Here we will discuss the mechanisms of the cardiac arrhythmias. There are three main mechanisms of the cardiac arrhythmias. Number one is the automaticity, number two is the triggered automaticity, and number three is the phenomenon of the re-entry. In this video, we will particularly discuss the increased automaticity. To establish the concept of the increased automaticity, I would like to show you this diagram. First of all, we should clear that what is the automaticity. Automaticity is defined as the property of any excitable tissue which can undergo the depolarization spontaneously. If some cardiac tissue develops the high automaticity tendency, it means some cardiac tissues develop the power to produce the depolarization spontaneously, but very rapidly, which start tachyarrhythmias. SA node, it is the SA node cell. SA node work as the pacemaker. SA node cells cause the depolarization spontaneously. Here I draw the diagram of the SA node cell. The electrical activity of the SA node is showing in this diagram. In SA node cells, there are some sodium channels. These channels are known as the leaky sodium channels. We can say the leaky sodium channels because the sodium is passing through from the outside the cell into the inside the cell. When triggers into the SA node cells, the resting membrane potential cannot, it is the resting membrane potential, it is the threshold potential. I am going to say when this SA node is triggered, when triggered in the SA node cell, the resting membrane potential cannot really rest because of the incoming sodium channels, sodium ions. These incoming sodium ions take the resting membrane potential towards the threshold potential. These sodium ions influx takes the resting membrane potential towards the threshold potential. As soon as the resting membrane potential up to the threshold potential, there is an opening of the voltage gated calcium channels, that is lot of calcium coming in, and this produce the calcium dependent depolarization. Here in this red color, it's produce the depolarization due to the influx of the calcium, because so much calcium is incoming into the pacemaker cell, SA node pacemaker cell. The voltage gated calcium channel open, and the lot of calcium is coming in. It will make the it will cause the depolarization. Then there is an opening of the potassium channel. At this stage, when there is an opening of the potassium channel, and potassium efflux means that is a loss of potassium from the cell. It will take the membrane potential back into the back to the resting level. It means that membrane again repolarize. It is the resting membrane potential. Sodium influx moves the resting membrane potential to the threshold potential. Here is the calcium channels open, and influx of the calcium cause the depolarization called the calcium dependent depolarization. Here again the potassium channel opens. It will make the membrane towards the repolarization, and membrane become repolarized back into its normal resting situation. Now, how this automaticity, it is the complete of the cycle, how this automaticity increased. One method is that when epinephrine stimulates the G protein coupled receptors, also called the 7-pass receptors, and epinephrine stimulates the G protein coupled receptors at the SA node. On the SA node, that is, you can say that the beta 1 receptors or adrenoreceptors are activated, which stimulates the GS proteins, which eventually release the calcium. Inside the cell, and additional calcium comes in. Now we can say that when epinephrine act on this SA node, automatic tissues, it will load that tissue with a extra cation, or it load the tissues with the calcium. This added calcium which comes into the cell, that helps the cell to move towards the resting membrane potential more rapidly, and there is more frequent production of the action potential. More frequent production. It is the more frequent. Before the time, the dotted red lines shows the rapid action potential producing due to the more influx of the calcium. We can say that the normal automaticity is enhanced or increased after the action of the epinephrine on the SA node, and SA node will be firing more frequently. If SA node will firing more frequently, we can say that this is the sinus tachycardia. Hopefully you will be understand about the increased automaticity of the mechanism of the cardiac arrhythmia. Thanks for watching.